Okay, so let's start this week's session. And okay, so this is the first question. And here, what do we have to find? We have to find the pole due to the output impedance, right? So uh, let us see how to solve that. So we had done this. Okay, we have not done the transfer function analysis earlier, and now since we have the resistances and we are considering the capacitances also at the output, so now we will have some RC components that will come into our transfer function and give us the poles and zeros. Okay, so let us see how to solve this one. Yes. Okay, so let us do this. So I'm just drawing the circuit again. We have the source resistance RS and we have the out. So this is, if you see, it is connected in common drain mode, right? There is no input at the drain. We are taking output from the source and input is given at the gate. So it is common drain mode. And please stop me wherever you feel that you do not understand something. Okay, so we have to find the pole at this node, right? So for that, what we need is we know that pole at any node will be given by say pole at output node equals to 1 by RC, right? Let me write it R equivalent. And what is R equivalent? Okay, so let's say R equivalent is RS parallel with, so what it is parallel with the impedance here, right? So okay, so here this is the capacitance and there is will not be coupling here, but here this is uh, there will be some resistance offered from the source terminal also, right? So it will, the output impedance here will be parallel of RS and that parallel source resistance. Okay, so let us see what is the resistance at the source terminal of an uh, so if I see Z out here, so to find Z out, what we do is we apply a test input V, find the test current I, and V by I gives us Z out. So if I solve this, I'm not solving it completely. You can simply, you know how to do it. ID equal to GM VGS plus GD VDS. So GM will be GM minus V, and GD will also be minus V. I equals to, so okay, and it will be minus I. Yeah. So V by I equal to 1 by GM plus GD plus GD. Right. So if you see, it is 1 by GM parallel with 1 by GD. So these two are equivalent, and GD in question it is given at Z out. Oh, sorry, R it is given at RDS. So I'll write it as in terms of RDS, 1 by GM parallel with RDS. Right. So what we have here is Z out, which is RS parallel with 1 by GM parallel with RDS. Okay. So let us see if you want to solve this. So okay, I'll not solve it. You can solve the parallel combination easily. So you can take two at a time. First solve these two, then solve these two, or do these two first, then solve the parallel of both. It will be the same thing. Anyways, and the equivalent capacitance is CS plus CGS plus CGS. We just have to see uh, what are all the resistances and capacitance that are connected to this node. So here CS is connected, here is the ground, and here CGS is connected. So okay, so let us try to. So pole, let me take it on the next page. So pole equals to minus 1 by RC to minus 1 by RS parallel 1 by GM parallel RDS CS plus CGS, and if we solve it, we should get in the formulation RS plus RDS plus GM RS RDS whole divided by RS RDS CS plus CGS. So this will be our pole, and okay, yeah, minus will be there. So if you solve it, put the value. So we have R, we know RS, RDS, GM, and everything we know in this. So if we just solve it, we will get, it should be minus 145.38. So I have not solved it, but yeah, this is the formulation. You just have to put the values in this, and you will get your answer. Any doubt in this part?
So
No, sir.
for calculating C equivalent, R should be 0, sir, right?
Sorry.
For calculating C equivalent, R should be 0, right? RS should be 0, right?
Why?
How
What
to
does
calculate
RS
C
has
equivalent?
to? So C equivalent is just, so what if you see? Okay, let me see. Yeah. So here it will be grounded actually. So this CS is there between at the V out node, right? So if I take the CGS, so do you remember the Miller theorem that I talked about last time? So if there is any, let's say this connected between input and output node, so it can be resolved here in the input as, let's say, minus A times CGS, and here it will be just CGS. So C equivalent is nothing, just the parallel of these two, and in capacitance parallels, just some, you just add them, right? C equivalent is CS parallel with CGS, and if you solve it, it is just CS plus CGS.
Okay, sir.
Anything else? So should we move ahead?
We can move ahead, sir.
Okay. So in the next question, we have to find the zero due to the short circuit current. Okay. So okay, short circuit current. Okay, fine. So let us draw the circuit and see again. Let us see. V in, we have CGS, and so this is V out. So now they are talking about short circuit. So we will short V out, and okay. So let's say the current I short circuit is flowing through here. So one of the current component would flow through here, and one current, the ID current will flow here. Right. So let me name it. Let's say I1 is this. This is ID is I2. So ISC equals to I1 plus I2. Okay. So what is I1? I1 equals to GM VGS plus GD VDS. Now there's no VDS. VDS is zero since we have shorted the output. So this is also shorted. This is also shorted. So VDS is zero. So it's just GM VGS, and VGS is nothing but V in, right? If this node is ground and this is V in, so VGS is V in. GM V in is I1, and this current sorry, I2, it is I2 minus T. And what is I1? I1 is nothing but V in minus 0 by 1 by SCGS, right? It is SCGS V in. So ISC is SCGS V in plus GN V in. So if I take SISC by V in, equals to GM plus SCGS, and let us take it in 1 by SC form to get the 0. So let's take GM common. 1 plus SCGS by GM. So this is the 0. So 0 is minus GM by CGS. And if you solve it, you will get minus 198.648. Is this part clear?
Clear, sir. Got it.
Okay. So let us see the next part. Um, okay, so they are saying that in this part, we earlier we had the same circuit, but now in the same circuit they are adding a resistance at the source RS and then giving the input Vn. So what will happen then? So so if you see like if you have seen the video, so this is actually the practical situation. So this common drain circuit is actually used as a buffer, right? So it is used for impedance matching. So the output generally where it takes the output, it will have high impedance. So we need to take care if of we need to consider in our analysis this source resistance. So that is why they have told here that in a practical situation it will have a large source resistance. Okay. So anyway, so what do we have to find? We have to find the output impedance. So we know what for output impedance, what we have if we have to find Z out here, we just apply test input V here and pass a current I there, and V by I gives us Z out. So we will do the same thing here also. Let me draw it. CGS V out. Okay. So we have to find Z out here, and input is actually connected here, but while finding Z out, we disconnect the input. We connect our test input here, V and I. So I'll just remove this. Okay, let it be capital I. So, okay. Uh, Let the current in this branch be I1 and current in this branch be I2. Okay. So I1 is nothing but minus ID, right? Or let me write it this way. ID equals to minus I1. If this is ID. We know ID equals to, sorry, GM VGS plus GD VDS. So now, okay. So if this here is, if at this node it is V, and we cannot say that this node is at ground, right? So VGS will not be equal to minus V. We need to find the voltage at this node. And if we see this node, what is this node? Let me draw it like this. CGS and RS. So here it is V, here it is ground. We need to find the voltage here. Let us call it VG. So it is just simple voltage divider. So if we solve for it, let's say, so VG equals to uh, RS by RS plus 1 by SCGS into V. So if I just solve it, SCGS R in RS into V divided by 1 plus SCGS RS. Okay. So we know VG. So let me write ID equals to minus I1 equals to GM VGS, okay, plus GD VDS. Okay. So let me see. GD common. Okay, so they are saying RDS is infinitely large. That means 1 by GD is 0. So I'll ignore GD. So it is GM. What is VGS? VG minus VS. VS is V. So it will be SCGS RS V upon. Uh, Bhuvnesh, can you please turn off your mic, please?
I'm sorry.
Yes, no problem. CGS RS. So this is VG minus, and at source it is simply V. So this is this, and yeah. So let it be. Now I'll write I2. So I2 is the simply the current flowing through this path, right? So I2, let me write it. Okay. It is I2. So I2 is simply V minus, okay, yeah, V minus 0 by RS plus 1 by SCGS. It is V SCGS times V by 1 plus SCGS RS. Okay, so now we know I1 and I2. We can write the I. So let me write it. So okay, I equals to I1 plus I2. I1 is SCGS RS. Let me take V common. GM SCGS. Okay, one more thing, it will be negative, right? This is minus I1. So I can get this. Okay. So if I take V common, 1 minus GM.
SCGS. SCGS.
1 second, my iPad got stuck. Sorry. Let me just copy these two here. And this. So I'll write I equals to I1 plus I2. So let me write I2 first. Let us write I2 first. To SCGS. What am I writing? CGS by 1 plus SCGS RS. Just take V common plus, okay, what am I missing? V is simply 1 minus SCGS RS divided by 1 plus SCGS RS. It will be GM here. Is this correct? I'm missing something or what? Okay. So if we solve this, V SCGS by 1 plus SCGS RS. If we take LCM here, so I should get GM, and I will just get plus 1 plus SCGS RS. Okay. So It will be, let me write it completely so you don't get confused. 1 plus SCGS RS minus GM SCGS RS. Right. So these two terms will cancel, this and this. So we will only be left with GM by SCGS RS. So finally, what we will get is V SCGS plus GM divided by 1 plus SCGS RS I equals to. Okay. So Z out is V by I. Let me take another page. Currently we have I equal to V times SCGS plus GM divided by 1 plus SCGS RS. So V by I is 1 plus SCGS RS upon GM plus SCGS. Okay, so this is Z out. Is there any doubt till here? It is just simple calculation. So if you just understand what I've done here, the voltage division to find VG, and simply I've just applied ID equal to GMVGS and ID is minus I1, and I2 is just the current flowing through this branch. It is simple KCL. See this? So then I've just added them, and it is just simple mathematics. So at the end, you should get this. So if you do not understand, please see it once more. And okay. So what is being asked in question is we have to find it at a frequency of something 3.2 gigahertz, right? So how to introduce the frequency component is we will put S equal to what is S? S is say j omega, or we can write it as j 2 pi f. We are given in terms of in hertz, right? So f1 is given as 3.2 gigahertz or megahertz or whatever it is given. I don't know. I'm not going to put it. So z out will be 1 plus j 2 pi f1 CGS RS upon GM plus J 2 pi F1 CGS. Okay, so just put the value of F1 and you have to find, then take its magnitude. So when you take the magnitude, it will be, if it is A plus IB, so the magnitude is under root A square plus B square simply, right? So that you have to solve, and so you can solve separately for denominator and numerator and then just divide. So if you solve it, you will get Z out as 42.99. Okay, and it will be kilo ohms. So if F1 is 3.2 gigahertz, rest everything is given. I think CGS is given and RS is also given, and GM is also given. Okay, so is there any doubt in this?
No, sir.
No, sir. You can.
Okay. Okay. So next part is also same. We just had the different frequency. So if you put it, you will get F2 is 28K. So if you put in the same formula, you will get Z out as, let me see, 861.336 ohms. Okay. So earlier we had F1 equal to 3.2 gigahertz. Z out was 42.99 kilohertz. So if you see when frequency is reducing, Z out is also reducing. So fifth question is exactly asking this. So what kind of output impedance is this? So what are the kind of impedances that we have? We can have resistive, inductive, capacitive. So let me write resistive, capacitive. So resistor is simply R, right? So it is independent of frequency. capacitance is 1 by SC. So when frequency increases, let's say XC decreases, and inductive is S into L. So when frequency increases, XL increases. So what did we have? When our frequency was increasing, our readout was increasing. So our load is of inductive. So not load, I should say our output impedance behavior is inductive. So we will have inductive behavior. Is this clear?
Okay.
No. So six is just theoretical. We do not have to solve anything. Just you have to analyze this. So I'm not going to do that, and you can just read through it and try to solve it. It is 7 and 8. Let's solve at last. Let's go to question 9. Okay. So we have to find the gain margin. Okay. So okay. Let me first what we is given. We are given what are the poles system has and has a right of plane 0 at 40 megahertz. Okay. So how will be our HS? Just should be there is okay. So let's say A is the gain DC gain 1 minus okay should be the poles will come. Okay. So it is said it is told that it has right half plane 0. So if it is lying in the right half, so we will have 1 minus S upon let's say WZ, and the poles are on left half only if it is not given by default, so it will be 1 plus S upon WP1 plus 1 plus S upon WP2. So this is how our transfer function will look like. And if we see the angle of H j omega, angle will be minus tan inverse omega by omega z minus tan inverse omega by omega p1 minus tan inverse omega by omega p2. Okay, so okay, so what is gain margin is? So gain margin is so let me say gain margin. So uh, so gain margin is the
Minus 20 log of.
yeah, that is true. But how do you find gain margin? Is first you calculate what is the frequency at which your phase becomes minus 180 degree, right? You first you find this frequency or let's say omega naught. So uh, you find this frequency and then you put it in, then you find the magnitude, and then that gain will give you then that gain will be the gain margin. So okay, let us try to solve it and it will be more clear. So what I said is first I need to find the frequency at which this angle is minus 180 degree, right? So okay, so first of all is why are we interested in 180 degree? So when we have our system, let's say this is HS, we all find this gain margin, phase margin for the worst case. So the worst case is when we have unity gain feedback, right? So then feedback is one. So our transfer function is simply HS equal. Okay, let me not say the closed loop transfer function will be HS upon 1 plus HS, I think. And if HS equals to minus 1 at angle 1, so If h is equal to minus 1, then CLTF will become infinity. That is, it is unstable. So we have to find like how far are we from this unstable condition. So we put the angle as minus 1 means what? 180-degree angle, right? So we put angle as 180-degree, then we see like are we at how far are we from this gain of 1? That gives us the gain margin. Is it clear? What is gain margin?
Okay, clear, sir.
Okay. First we'll put it as minus 180. So so fine. So we know that okay, tan inverse x plus tan inverse y equals to sorry plus tan inverse y equals to tan inverse x plus y upon 1 minus xy. So so I have solved it already using these. So using this equation, first we will apply to these two, then we will apply to whatever we will get something in terms of tan inverse, then we will apply in these two. So let me just write it what we will get. Let me just put it here. So if I apply it to these two first, I will get so minus tan inverse uh, omega omega z plus omega p1 divided by omega z omega p1 minus omega square minus tan inverse omega by omega p2. Now if I apply it at these two, I will get this minus tan inverse minus 180 equals to minus tan inverse. If we solve this, we get omega z plus omega p1 omega times omega p2 plus omega z omega p1 minus omega square whole upon omega pz sorry omega p2 omega z omega p1 minus omega square omega z omega p1 omega p2 plus omega z omega p1 minus omega square. It seems very complicated, but it is not. Anyways, so I have just simply used these formulas to find to solve this, and I'll get something like this. Anyway, so if we take the tan this side, let me cancel minus and minus. So tan 180 will be 0. So we will get this term equal to 0. So let me copy it. Copy this term. So this term equals to 0. So the whole denominator will go to 0, right? If I take it multiply here. So then I'll be left with okay. So if I if what I will be left with omega z plus omega p1 omega dot omega p2 plus omega z omega p1 minus omega square equals to 0. If I solve it, I will get uh, it will be minus omega cube plus omega times omega z omega p1 plus omega z omega p2 plus omega p1 omega p2. equals to 0. So let me copy it again. So we have to find the omega frequency at which our phase was 180 degrees. So we are trying to solve for omega. So if I paste it, so if you see omega cube equal to omega times omega z omega p1 omega z omega p2 plus omega p1 omega p2. Omega. Let me cancel it. So this is omega square or omega naught square. So okay. So we know these frequencies, right? This we know. This we know. We know all the poles and zero frequency. We also know the DC gain. So we can find this. Let me call it omega naught square. Right, it is omega naught square. So if we see, we know omega p1 we know, omega p2 we know, omega z we know. So we can find omega naught square. So now gain margin is k equals to 1 upon plus h of j omega. Okay, so it will be, so what was h j omega? Let me write again. H of j omega naught is equals to k times 1 plus omega naught by omega naught. Sorry, we have to put the omega naught. So the omega z whole divided by 1 plus omega naught by omega p1, 1 plus omega naught by omega p2. I have to write j omega naught here. That's equal to j omega naught. So if I take its modulus, it will be something like this, right? 1 plus omega naught by omega p1 whole square, not whole square, square. 1 plus omega naught by omega p2 square divided by a square. 1 plus omega naught square by omega z square. So all these values we know we can find it and it will come out to be 0.35. And if we take its 20 log in for dB, we will take 20 log 0.35. It will be minus 8.95 dB. This is our gain margin in dB. Yeah. So is this clear? I know it was like very lengthy and complicated, but it is fairly easy if you try it on your own. You just have to find this omega naught frequency, then just put in the formula. Is it clear?
So we can proceed, sir.
Yes,
Okay.
sir.
So fine. So last question is, we have to find the fail margin is 60. What is the ratio? We have to find the ratio of the two poles such that the phase margin is 60 degrees. Okay, fine. And ratio is greater than 1. Okay. So again, we just had the two poles. Now they are not talked about 0, so we will not take the 0. So our transfer function will be a naught upon 1 plus s upon omega p1, 1 plus s upon omega p2. Right. So, okay. So for phase margin, what we do, we equate the gain to 1. We find the frequency omega naught at which gain equal to 1. So let me equate it. So if I equate it to 1, I will get a naught equal to 1 plus, let me write it as j omega naught by omega p1, 1 plus j omega naught by omega p2. If I take the magnitude, a naught square, 1 plus omega naught square by omega p1 square, or if I, let me not write square, 1 plus omega naught square by omega p2 square, then a naught square equals to Okay, fine. Let it be left like this only. So this is A naught. And if we try to actually solve for omega naught here, it will be very difficult. So we will not take that approach. We'll try to solve it somewhat differently. So, okay. So angle h of j omega naught. Let's see this. Angle h of j omega naught equals to minus tan inverse omega naught by omega p1 minus tan inverse omega naught by omega p2. Let's say this is the phase margin, so it is phi minus phi. Okay. Yeah. So phi is actually your phase margin. Phi is the phase margin, and pi we have to equate it to pi because we have to find it how far it is away from pi. How far the phase is away from pi is our phase margin. Okay, so this is the phase. So if we take cos of this term, so cos phi minus phi equals to minus cos phi equals to cos of tan inverse omega naught by omega p1 plus tan inverse omega naught by omega p2. All this. Okay. So let me copy it to the next page. So yeah. So okay, fine. So let us see this. Uh, this is omega naught. This is omega p1. This is the some angle. So what is tan? Tan is omega naught by omega p1. This is this. So now what will be the cos? In terms of cos, it will be, sorry, in terms of cos, it cos inverse, it will be uh, omega naught. What is cos? Cos is P upon
Base
B.
value.
Yeah, P upon B. So it
Omega
will be,
P1.
sorry, this is
Omega
B up,
P1 by B.
yeah, fine. B upon P. So it will be omega P1 by under root of omega P1 square plus omega naught square. Is this correct? In terms of cos of, let's say, this angle is whatever this angle is. This is actually the angle. So for cos, is this correct?
Correct.
Okay. Similarly, for this term, we will have omega. We will have something different. Okay. So, anyways, so how we can what and why am I doing this? So let's say this is angle A. This is angle B. I have written it for angle A. This is cos of A. So we know cos A plus B equals to, I think, cos A cos B minus sin A sin B. Please verify this. I do not remember the identity. So if this is it, similarly we will find cos B equal to omega P2 by under root omega P1 P2 square plus omega naught square. And similarly sin will be omega naught by under root omega P1 square plus omega naught square, and sin B omega naught by under root omega P2 square plus omega naught square. So we will now put it here in this expression cos A plus cos B. We will put it cos A cos B minus sin A sin B. Okay, so we put it, if we put it there, we will get uh, cos minus phi, sorry, minus cos phi. We get this minus cos phi equals to cos A cos B will be omega P1 omega P2 divided by under root of omega naught square plus omega P1 square omega naught square plus omega P2 square minus sin A sin B omega naught square divided by under root omega naught square plus omega P1 square P1 square omega naught square plus omega P2 square. Okay, fine. So, uh, if you see, I think in one of the videos, cos phi sir has given this formula as of uh, as formula of phase margin as 1 by a naught 1 minus omega naught square by omega 1 omega 2. Sir has given it like this. So I'm not trying to, I won't derive it from where it comes. It is fairly easy and he has done a similar thing. So you can see it there from where this comes. Uh, it comes from here only. So, okay, so if I tell you from where it comes, it is easy, I think. I can tell. What is A naught? If we see again. So this is A naught, right? So if I let me copy it, fine. It will take some time, but let's solve this completely. So A naught will be, let me take omega P1, omega P2 common. So it will be under root 1 omega P1 square plus omega naught square, omega P2 square plus omega naught square, right? So, so what are these terms? These terms are A by omega P1, omega P2, right? So if I do this, I will get this. Can you see this from here? If we put this A here, we will get this. Are you following?
Yes, sir.
Okay. So you don't have to do anything. So let me write it just like this: A upon omega P1, omega P2 equals to this, and this term we have here. So when we put it in this formula, we will get, after solving, we will get this. This is the final expression. So anyways, so let us take it forward. So 1 plus a naught cos phi was to omega naught square divided by omega 1 omega p1 omega p2. I'll just rearrange this equation and uh, okay, and we know a naught square is uh, 1 plus omega naught square by omega p1 square 1 plus omega naught square by omega p2 square. This we had solved first. So if we solve it, okay, let us solve a naught square minus 1. So if we solve it, we will get omega naught square by omega p1 square plus omega naught square by omega p2 square plus omega naught to the power 4 upon omega p1 square omega p2 square. Okay, then then what we will do is we will divide this by 1 plus cos phi 1 plus a naught cos phi. So a naught square minus 1 divided by 1 plus a naught cos phi. So why are we doing this? Ultimately, we want to find. something that is omega p2 by omega p1 or omega p1 by omega p2. So we are trying different arrangements to find that. So if I see this, it will be omega p2 by omega p1 plus omega p1 by omega p2 plus omega naught square divided by omega p1 omega p2. So here if you see now I have somewhere reached uh, to get the ratios, but still I have this extra term. So this extra term is simply this only. So I'll just subtract this quantity again from here. Next step is a naught minus, sorry, what was it? A naught square minus 1 divided by 1 plus a naught cos phi minus 1 plus a naught cos phi. Then we will simply, then this term will go away since this is this. We will be left with these two only. Omega p2 by omega p1 plus omega p1 by omega p2. Okay, so now here we have to take an assumption that one of the poles is very large. So let's say omega p2 is much greater than omega p1. Then omega p1 by omega p2 is very small in comparison to omega p2 by omega p1. So we will ignore this and we will get this as the ratio. So omega p2 by omega p1 equals to a naught square minus 1 by 1 plus a naught cos phi minus 1 plus a naught cos phi. So phi we know is given as 60 degree, a naught is given as, I think, what is a naught? 1328, 1328. So if you solve this, you will get the ratio as 1987. That is the answer. So again, the last two questions are like fairly mathematical, but they are easy. I'm just doing mathematics, simple rearrangement. They are not very difficult. Any doubt in these in this part also? So for your question, you just have to use this formula and put the values that are given a naught for you and the phi for you, whatever they are given in your assignment, and you will get your answer. Is it clear?
Right, sir.
Yes,
Okay.
sir.
So I think we have left a few questions. Yeah. Let me see. So question 6, you just have to read. Uh, I won't be solving this. And okay. So in question, so let me copy this.
Venkat, please mute your mic.
So in this question, we have to estimate. We have to estimate the two poles. So we have to make an approximation that one pole is much greater than the other. So will be a very long procedure. So I won't solve it completely. I'll just tell you like what you have to do. So okay. So this is the circuit that we have to solve. So how you will solve it simply is okay. Let me write what is C1 and C2 first. So C1 will be CdB1 plus C SB2 plus CGS2, and C2 will be CdB2 plus CGD2. So if you analyze this, you can see that these are correct anyways. So to solve this again, so to find the transfer function, you will just apply KCL everywhere. You will go from here. One current will flow from here. One current will go here. Another current go here and goes here. So you will with those current equations, you will just find V out by V in. So So if you solve it, so you know that it is a two-pole system, right? They have stated that it has two poles. So what it will look like is denominator will be something like uh, 1 plus s upon omega p1, 1 plus s upon omega p2. This omega p1 and omega p2 will be something in form of R and C that will be combination of these and maybe GM, GD, whatever, right? So anyways, you will have to solve V out by V in, then compare it with this. So okay, so if I solve it, the denominator part, let us take the denominator. So to solve it, what I will get I will get is 1 plus s square upon omega p1 omega p2 plus s 1 upon omega p1 plus 1 upon omega p2, right? And if I compare it with this equation, let's say 1 plus a square plus bs, right? So a is what? A uh, this term 1 upon this is a and b is this. So if let's say one of the poles is much larger, that is, let's say omega p2 is much greater than omega p1, right? So what we will get, b equals to uh, if 1 upon omega p1 plus 1 upon omega p2. If omega p2 is much larger, so b will be approximately equal to, this term will go to 0. If omega p2 is much larger, it will be approximately 1 b equal to 1 upon omega p2 p1, sorry. And similarly, when you put this, we know a is what? 1 upon omega p1 omega p2. So okay, so this is b. So omega p2 is, let me take another page. So omega p1 equals to 1 upon b, and omega p a equals to 1 upon omega p1 omega p2. A equals to b upon omega p2. So omega p2 is b by a. So this is how you will have to estimate the pole. So what you have to do is solve for VO by V in, then make the equation in this form, 1 plus a square plus bs. Then you can simply estimate what is omega p1 will be 1 by b and omega p2 will be b by a. Okay. And then you have to find, I think, the ratio. So what will be the ratio? What is the ratio of the two poles? Okay, so ratio will be simply omega p1 by omega p2, or the opposite of that, I'm not sure. So 1 by b divided by b by a to a by b square maybe. No. Or if it is omega p2 by omega p1, it will be b square by a. So whichever is greater than 1 will be the answer. So you have to find these or this. So I have missed the step that where I actually have to find this. You have to do it yourself. Next, when you form the denominator, you just have to compare it with this and just find these. Those will be your answer. Okay. Is it fine?
Right, sir.
Okay. So let us take the last question also quickly. So the last question is fairly easy, I think. Okay. Again, here C1 equals to CDB1 plus sorry, CSB2. C2 is equal to CDB2 plus CGD2. plus CSB2 plus GS2. Okay, yeah. And you just have to use these formulas that are given in this. So I don't know if they are visible, but these are the formulas of the poles. So you just put these values. I'll write them again. Maybe they are fine. So pole 1 equals to minus 1 by C2 RO1 plus RO2 plus GM2 RO1 RO2, and P2 is minus RO1 plus RO2 plus GM2 RO1 RO2. Okay. Minus is common. Divide by RO1 RO2 C1 plus CGD1. So these formulas are already given in question 6. You just have to find what is C1 and C2 and then just put the values and you will get the answer. And answer here you will get is 173. Maybe P1 by P2 or P2 by P1, I'm not sure, whichever it is greater than 1. It will be 173. Okay. So these are all the questions in this assignment. Is there any doubt?
Sir, in the earlier assignment,
Yeah.
when we evaluated question number 6, we got 325.67, sir.
Let me see what was question number 6.
Uh,
Yeah. Okay, you have to find FT.
yes, sir. 2.77 whole square into whatever we got FT in question number 5. That is the answer.
Okay, yeah.
Even when we followed the same, 2.77 whole square into the answer from the earlier one is 42.468. The answer we got 325 point something, right, which is very nearer to 332, but they have given the answer as 307.45, sir.
Oh, have they given the explanation in the answer, like if they have used some other technique or something?
But the one we got is nearer to 332.
So I'll need to check that.
Yes, sir, yes, please, sir.
So I'll look into it and let you know. Maybe you can email me once.
Okay, okay, sir.
Okay. Anything else in this week's assignment or any
No,
other
sir,
thing?
no, sir.
Okay. So let us close for today, and I will post the video and also uh, the slides for today in the sheet that we have. Okay. So thank you, everyone.
Sir. Thank you, sir.